Welcome back everyone to the final installment of this tic-tac-toe creating journey. In this video we're going to be looking at creating a computer that can play against the player with reasonable accuracy. The second thing we're going to be looking at is what happens if the player ties. And the last thing we're going to be looking at is how we can restart the game. The first thing we're going to have to do is we're going to have to check if there is a tie. And to check if there's a tie, we have to actually look at all of the pieces on the board, and we can actually sum that up in an all pieces function. What I'm just going to do is I'm going to create an all pieces list. And I'm just going to append every piece in the board to that list. That'll be all pieces dot append, and then we'll select that piece, the row, and the column. And then we'll return all the pieces. Pretty simple. We can implement this into our check win function. And it'll just be if all pieces, and we'll supply the game board, as it usually is. We'll return a tie if all of the pieces are not none. Recall that none is equal to a false value. So all checks if all of them are true, and all of them will be true if all of them are taken up. And similarly, we're going to actually want to eliminate all of the winner messages that we had before, because what I found is that we can actually use this check win function to consistently check whether the computer or the player has won. And just to do that, we're going to need to remove all visual user interfaces just to make sure that the gameplay isn't crowded. Instead of returning nothing, we'll return win every time a user has won. It doesn't actually matter which user has won, because we'll be able to see that in our main program, but for all of these, we'll return a win, and if all of them are false, or don't return, then we can simply return a false, which means nothing was returned. Next thing we're going to want to do is replace these redundancies by using a for loop. So we'll just say for piece in this list, X and O. So it's just going to be iterating over those two each time, or like toggling, you could say. And we'll just play that piece. This play function is still going to come in use. We'll actually restore the result in a variable called result. And we'll say if the result is equal to win, or the result is a tie, then execute the following. We're just going to display the board to the user. And let's just add some decoration here. We'll separate the result with some dashes. Maybe 20 is good on both sides. And we'll say if the result is equal to win, then we'll have a custom message here. We'll say print the piece dot upper and wins right after that. And you might recognize this if you look a little bit higher. This is just our winner message function. So now we can actually just delete this. If it's a tie, or otherwise known as else, then we'll just print tie. And now let's see how this runs. So I'll do a run command, python main.py. Let's see how this goes. We'll paste our piece in position 1, and the other player will place that piece. There you go, now I should win. And the game keeps going on because remember we removed that exit function that was in our winner message, but we'll be able to deal with that by just breaking out of here. So in this tutorial, I should mention that I'm not going to be doing really any error checking, because those just sort of get into the nitpicking details. Instead, I'll just be looking at covering the cores. Yeah, and it says tie. Now let's actually program our computer. So let's make a function called computer move, because this is going to be supplying us with the coordinates on the board of where the computer is going to be placing its pieces. And this computer actually needs some hypotheticals. So like, let's say if we were to hypothetically place a piece here, would we win, or would the user win, or would nobody win? And that's the three things I just want to check for. So we're going to need a board for this function. I'm going to do something similar we did in the part 1 of this series, where we just iterate over every piece, but also count the row count and the call count, or the column count. And we're just going to be using our enumerate function for this. If you're not familiar with enumerate, I highly recommend checking out that video that I released on the enumerate function. So this just iterates over every piece, and we'll say if column is equal to none, so if there's nothing in that column, then we can actually execute the following commands, because if there is something in that column, we just want to actually disregard it. So let's first check if X will win. So what we can do is actually assign this column, recall that it's none right now, we'll assign this column to X, hypothetically. So that's the player's piece, and we'll check if the player wins by doing that move. If they do, we want to actually block that move, so we'll place an O there instead. And we'll return our row count and our call count. But what if we can win? We'll hypothetically place our piece in that board, and if we win, then similarly we'll return row count and call count. And then we actually have to reset that position on the board, so that if none of these are true, then we can actually reset our hypotheticals and move on to the next column without it completely disregarding whether it's 1 or not. So what if the X can't win or the O can't win? That just means we're too early on in the game. And it's better if we just make a random move here, so it doesn't get too complicated with all these strategies and possibilities with tic-tac-toe. So we'll just assign a random move to a random integer. We're just going to be targeting the indexes of the columns and the rows, or the rows and the columns, I should say, respectively. Now, random is not defined. That is actually in the random library for Python. So that'll be from random import randint. There you go. Oh, and I actually have to assign this. Of course, I didn't actually put my equal sign here. And then we'll actually do a while loop to make sure that that random move isn't in a place that is already occupied. So again, if that area is none, we'll reassign the random move if it is in the wrong area. And then we'll return that random move as our coordinates, or as our row count and our column count. The last thing we have to change is the play function, so let's find that. So we'll keep this print piece right here, but we'll say if the piece is equal to O, or the computer's piece, we'll pass it for now, and we'll say else do what we usually did. So here we'll actually utilize our computer move function right below, and we'll place a piece using that place piece function, although that is sort of unnecessary at this point, but we'll use it either way now that we've written it, and supply it to the row and the column coordinates that are stored in our move variable. So that should work out. Let's just run our program again. So we'll place a piece at the top. List object is not callable. That was in our computer move. Right, the problem we did here is we're not actually targeting the indexes of this list. Instead, we made it so the random move looks like a function. So we'll just change those to square brackets. So I actually just noticed that we have lots of redundancies in our computer move function, and we can actually just compact this into a few lines. So we can actually remove this line. Let's just remove our comments here as well. And we can actually just toggle the pieces now, because that line above where it said column is equal to O actually wasn't doing anything. It was just going to be reset either way, and it was going to happen anyway. So we can actually just add a for loop to iterate over them by just calling on piece. And then here we'll just say the board row count, call count is equal to piece. And once we're done with that, we'll just say it's equal to none. Oh, and I should probably indent all of this. So now I believe that should work. But the only thing I really need to change here is the fact that the game doesn't break out once a player wins. So we'll ask for an input. We'll just assign it to restart, and we'll just ask the user if they want to play again. They can provide a yes or a no, but really we're only going to be checking for that no. And if they select no, we'll just say if restart.lower is equal to no. So we're converting that answer to lowercase just for some extra error checking. Then we'll break out. Otherwise, we'll restart that loop once again, except create a new game. And remember what happens when we create a new game. That just creates an empty board. But it does take a bit more space in memory, so I guess it would be better to actually have a dedicated function to that, so we can just manipulate the currently playing game, but it achieves what we need for now. Now let's try playing this game. So I'll just place my X piece at the top left, and it just does a random move, and I'll try winning on the top row, so it should defend, and it did. Now I can defend against that, and it should say tie, and it should ask us to play again. We'll play again, and it creates an empty board, but this time O starts first, so it's a good toggling mechanism. And it was unintentional because, as you can see, it's in its for loop. So if I went and then I said for the game to end, then O is going to go first, and then O will tell the game to end. And I guess that's pretty much it for this program, because there's just anything else is sort of like optimizing the amount of code that we have, or the efficiency of the code. And I can see that there's now some useless functions, like up above where we have this place piece function we created in part 1, or part 2, may I say. It doesn't really serve a purpose, because all I tried to do was make it so that it could actually be more internalized and grouped together, but now we can see all of these functions are no longer grouped together, and they just rely on that board argument. And heck, we don't even need that board argument. So a lot of these things don't need to be implemented, and the code itself can be a lot shorter. For example, these were here for demonstrated purposes, but these could be automatically generated if I wanted. Or I could just directly embed them inside this for loop. It probably wouldn't be too pretty, but if I were to create like a list comprehension or a generator, for example, then it would suffice to say that it would actually be a bit more efficient. Otherwise, if you guys didn't find this tutorial too helpful, I recommend checking out other beginners tutorials on the topics that I was talking about. Because a lot of this was a lot for my learning, and just for you guys to see how exactly I was thinking about all of this. Because if I were to come back to this like a year in time from now, then it would look like all of this is coded kind of sloppily. But that's the learning process, and I believe I learned quite a bit from this. Yeah, if you guys do have any questions about what I've talked about here, then be sure to leave a comment and I'll be happy to answer any of your questions. And I also have a series of this on my blog as well, which has a lot of source code. And I'll be creating a GitHub gist for this, since there's only one file, and that's main.py. Despite the alacrity.yaml, you've probably been wondering what that is. That's just my terminal that I increased the font size with. So I'll make sure to link that down in the description so you guys can try playing with this game yourself. And if you want this to be a good starting point for other functionality, then I'd be happy to help you out. It'd be great to see your guys' code as well. So if you did enjoy this video, be sure to drop a like and subscribe for more videos like this. And I will see you in the next one. See ya!